There is a pipe coming out of the ground on a hillside in Geauga County, Ohio, and water is flowing out of it, not dripping. Flowing, steady, clean, cold. Enough to fill a 5-gallon bucket in under 2 minutes. There is no pump anywhere on this property. No pressure tank. No electrical connection of any kind running to this water system. The pipe is black polyethylene tubing, the kind you can buy at any farm supply store for roughly $6 per 50-foot roll. And the water it is delivering has been moving uphill continuously without mechanical assistance for 23 years. I stood at the end of that pipe for a long time before I said anything. The Amish family that built this system did not hire an engineer. They did not pull a permit. They did not call a plumber. The man who designed it learned it from his father, who learned it from his father, who learned it from a hand-copied document. That traced back to a Swiss Mennonite farming manual from the early 1800s. 3 generations of functional water delivery without a single motor, without a single utility bill, without a single service call. This video is about how that system works. Exactly how. And why modern well drilling and municipal water industries have spent 70 years making sure homeowners never learned it was possible. Stay with me. Because the physics behind this has nothing to do with magic and everything to do with a principle so simple that your grandfather would have been embarrassed not to know it. And once you understand it, you will never look at a water bill the same way again. I need to start with a number. Not the $6. A different number. The number is 33.9 feet. That is the maximum height that atmospheric pressure at sea level can push a column of water. It is a fixed physical constant. It does not change. It has not changed since water existed. Every pump system ever designed is working against that number in one way or another. Every pressure tank, every submersible pump, every municipal water tower, all of them are engineering solutions to the problem of moving water higher than 33.9 feet. Against gravity, using mechanical force to overcome atmospheric limitation. The Amish system does not fight that number. It uses a completely different principle, one that does not push water at all. It pulls it. And the mechanism that does the pulling costs $6 and requires no electricity to operate. The principle is called a siphon. And before you close this video, because you think you already know what a siphon is, stay with me. Because what the Amish figured out, and what the Swiss Mennonites documented 200 years ago, is not the simple siphon you learned about in a middle school science class. It is a continuous gravity-fed siphon system with a self-priming intake, a flow control valve, and a delivery architecture that can move water uphill across multiple elevation changes without losing prime. That is not the siphon you use to drain an aquarium. That is a water delivery system that can serve an entire farm. And it starts at a spring. The first thing you need to understand is that this system is not for everyone. It requires one specific geographic condition that cannot be manufactured or substituted. You need a natural spring, a creek, a pond, or any standing or flowing water source. That sits at a higher elevation than a portion of your delivery route, even if the final delivery point is higher than the water source. I will say that again, because it is the part most people get wrong. The final delivery point can be higher than the water source. The siphon only requires that one section of the pipe route goes lower than the water source at some point along its path. That low point is called the siphon's drop, and it is the drop, not the source elevation, that determines how high the water can ultimately be delivered on the far side. The physics is this. A column of water in a sealed pipe creates a continuous pressure differential between the high point of the pipe and the low point. The weight of the water descending on the downhill side of the system creates a pulling force on the water behind it, drawing it forward through the pipe. As long as the pipe remains sealed, as long as no air enters the system, and as long as the descent on the delivery side does not exceed the height of the water column on the source side. The Amish in Geauga County are not defying physics. They are using physics so precisely that they do not need to pay a utility company to do what gravity and atmospheric pressure will do for free. The man who showed me this system was named Eli, not the Eli from Lancaster County I have mentioned before. A different one. Eli Troyer, outside Middlefield, Ohio, 61 years old. Third-generation user of a system his grandfather installed in 1952. The original black pipe from 1952 was replaced twice, once in 1978, once in 2001. The design has never changed. The delivery point has never changed. The water has never stopped flowing in 72 years, except for 2 weeks in the winter of 1978, when the intake froze and Eli's father walked up the hill with a bucket of hot water and thawed it by hand. 2 weeks in 72 years. Your municipal water system has probably had more outages than that in the last decade. Your well pump has probably been serviced more than twice in the last 20 years. And every single one of those service calls cost money that Eli Troyer has never once spent. He walked me up the hill first. That is always where you start with this system. At the source. The intake was a shallow stone-lined spring box set into the hillside, maybe 3 feet wide, 2 feet deep, stones fitted without mortar. A wooden cover over the top to keep debris out and animals away. Water seeping from the hillside through the stone floor at a rate Eli estimated at roughly 8 gallons per minute. Not a river, not a creek. 8 gallons per minute from a seep in the side of a hill that most people would walk past without noticing it was there. The pipe entered the spring box through a fitted stone opening about 6 inches from the bottom. Not at the very bottom, 6 inches up. That gap is deliberate. It is the sediment buffer. Any silt or debris that enters the box settles to the bottom and never reaches the pipe intake. The pipe itself was fitted with a simple brass foot valve, a one-way check valve that costs less than $4 at any plumbing supply store. That holds the water in the pipe when flow is interrupted and prevents the siphon from losing its prime every time water is drawn at the delivery end. That foot valve is the most expensive single component in the entire system. From the spring box, the pipe runs downhill for approximately 200 feet. This is the siphon leg, the drop. This section of pipe descends 41 feet below the elevation of the spring box surface. 41 feet of descent. This is important. At sea level, atmospheric pressure can support a water column of 33.9 feet. Eli's system sits at approximately 1,100 feet of elevation in Geauga County, which reduces that atmospheric support slightly. In practical terms, Eli's system can sustain a siphon over a drop of approximately 38 to 40 feet at his elevation. His 41-foot drop exceeds that limit slightly, which is why his system includes a secondary air release valve at the high point of the siphon, a simple petcock valve, the kind used on old radiators, that allows him to bleed any accumulated air from the top of the siphon without disassembling the pipe. He opens that petcock once a month, releases a small hiss of air, closes it, takes 15 seconds. The siphon stays primed for another month. From the bottom of the descent, the pipe then rises. This is the part that makes people's eyes change when they first understand it. From the lowest point of the siphon, 41 feet below the spring, the pipe rises 27 feet before reaching the delivery point at the barn. The delivery point is therefore 14 feet lower in total elevation than the spring box. But along the way, the pipe went down 41 feet and back up 27. The geometry works because the weight of the descending water column in the downhill leg is doing the pulling. The rise on the delivery side is free, up to the limit of the pressure differential the siphon creates. 14 feet of net elevation difference between spring and delivery. 200 feet of horizontal distance. 0 electricity. $6 of black poly pipe per 50 feet. Now here is where it gets more interesting. Eli's system is a simple two-leg siphon. But the Swiss Mennonite manual his grandfather learned from describes a multi-stage siphon architecture. It can deliver water across terrain that changes elevation multiple times. Up over a ridge, down into a valley, up again. Each stage is a self-contained siphon, connected by a collection box at the low point of each descent. Amish farms in hilly Ohio counties have used these multi-stage siphon systems since the mid-1800s. This basic design predates the internal combustion pump by decades. It wasn't replaced because pumps were better. It was replaced because pumps could be manufactured, sold, serviced, and made dependent on fuel or electricity. The siphon cannot be sold or serviced. Once installed and primed, it runs for free until the pipe fails. Black polyethylene pipe, buried 6 inches underground, lasts between 40 and 60 years. The economics are not subtle. A submersible well pump and pressure tank system costs thousands for equipment and labor. It requires electricity, adding $30 to $60 to your monthly bill, and service every 7 to 10 years. Over 40 years, a conventional pump system costs the average homeowner $12,000 to $20,000. Eli Troyer's system cost his grandfather $40 in 1952 for pipe, fittings, and a brass foot valve. Eli has spent perhaps $300 on 2 pipe replacements in 72 years. The spring has cost nothing. The gravity has cost nothing. The physics has sent no bill. Before installation, I need to tell you about Andrew Risser. This system didn't disappear by accident. Risser's story is the clearest example of how it happened. He traveled rural Pennsylvania helping farm families. In his memoir, Risser describes visiting dozens of Amish and Mennonite farms in the 1950s using siphon systems. He described them as reliable, well-maintained, and functional, used for 30 to 40 years without service. Then, his office received a directive in 1958 to recommend against gravity feed systems. They were instructed to actively promote electric pump systems as the modern standard, citing sanitation concerns. Risser notes no specific sanitation failures or outbreak data were referenced in the directive. The directive arrived the same year 2 major pump manufacturers opened Pennsylvania distribution. Risser kept recommending siphon systems to Amish farmers off the record for another decade. He writes that not a single family maintaining gravity feed systems ever reported a sanitation problem. The directive was a recommendation, not a law, but county extension agents followed it. Within 15 years, institutional knowledge of siphon design disappeared from mainstream American farming. What remained survived only in communities that never trusted the extension agents in the first place. Here is how you build the system. If you have a spring, creek, or pond on elevated ground, even ground moderately elevated above a low point on your property, you can build this. The cost will be between $40 and $150, depending on distance and fittings. You will need black polyethylene pipe, 1/2 inch or 3/4 inch diameter. 3/4 inch will move 8 to 12 gallons per minute, enough for a household and small livestock. You will need a brass foot valve for the intake end, and standard barbed poly fittings with stainless clamps. You will need a petcock air release valve for the high point of the siphon. The first step is surveying your route. Walk the terrain between your water source and delivery point. You are looking for the lowest accessible point along any path between them. That is your siphon drop point. Measure the elevation of your water source, surface, and that low point. The difference is your available drop. If your available drop is at least 15 feet, you have enough to work with in most North American elevations. If it is 25 feet or more, you have a robust system capable of delivering water with meaningful pressure. Measure your intended delivery point elevation. Subtract it from the water source elevation. That net difference tells you the net head pressure. As long as your delivery point is not more than 10 to 12 feet above your water source, and as long as your siphon drop is at least 25 feet, the system will work. The second step is laying the pipe. It runs from the intake in the spring box, descends to the siphon drop point, and then rises to the delivery point. Bury the pipe at least 6 inches underground wherever it crosses open ground. Use continuous pipe with as few fittings as possible. Every fitting is a potential failure point, an air leak. Air leaks are the only real enemy of a siphon system. At the siphon drop point, install nothing. The pipe simply continues through the low point and rises. The fewer components at the drop, the more reliable the siphon. At the highest point of the entire pipe route, install the petcock air release valve. Drill a hole, thread in the petcock, seal with pipe tape. That is the entire installation. At the delivery end, install a simple gate valve for flow control. This stops water delivery when the tank is full without disrupting the siphon. The foot valve holds prime while the gate valve is closed. When you open it, flow resumes immediately. Priming the system requires physical effort and only needs to be done once. The traditional Amish priming method requires 2 people and a garden hose. One person fills the pipe from the high point downward in both directions simultaneously. The second person at the delivery end holds the pipe submerged in a bucket of water. When water flows steadily with no air bubbles, the siphon is primed. Close the gate valve, remove the fill hose. Open the petcock and release any remaining trapped air. Close the petcock. Open the gate valve. The water flows, and it does not stop. Eli Troyer primed his current pipe installation in 2001. He has not reprimed it since. 24 years of continuous flow from a one-time 15-minute setup process. I want to tell you about a second person before I close, Miriam Schlabach. She farmed outside Sugar Creek, Ohio, and used a 3-stage siphon system for 31 years. 3 delivery points, 1 source, 3 sequential siphon legs connected by buried clay collection pots. I asked her how often she thought about her water system. She considered the question seriously. She supposed she thought about it when it rained, because the spring ran better after rain. And she thought about it in January, when she checked the intake for ice. And she thought about it now, talking to me, 3 times a year. She thought about her water system 3 times a year. The rest of the time, it simply worked, the same way gravity simply worked. It was not a technology to be managed. It was a feature of the land that she had learned to use. I asked her what she would do if the system ever stopped working. She looked at me with particular patience. She said she would walk up the hill and look at the intake. Then she would probably bleed the air valve. And if neither of those fixed it, she would call her son, who helped install the system in 1994. That is the entire maintenance protocol for a system that has delivered water continuously for 31 years. Your well pump's maintenance protocol is a $200 service call and 3 days waiting for a technician. Here's what I want you to do this week. Walk your property. Look for elevation. Look for water, a spring seep, a creek, a pond, a wet area in the tree line. Look for a low point between that water and the place you want water delivered. You are not looking for perfect terrain. You are looking for 25 feet of available drop. If you find it, write the elevation numbers in the comments. Your source, drop point, and delivery elevations. I have been collecting these for 3 months and am building a response guide. It will tell you if your terrain can support this system and what pipe diameter and layout will work. If you have ever seen a gravity feed water system on a farm, I want to hear about it. Tell me what it looked like, what it fed, and whether anyone told you it was obsolete. Because I already know what those stories sound like, and I want them in this record. The knowledge Miriam Schlabach carries, that Eli Troyer inherited, that Andrew Risser quietly preserved. That knowledge belongs to anyone willing to walk their land and take 3 elevation measurements. You do not need a permit for gravity. You do not need a license to use a hill. You do not need a utility company's permission to use water that falls from the sky. The pipe costs $6 per 50 feet. The physics is free. The water is already there. The only thing that was ever missing was the knowledge that this was possible. And now you have it. Next week, I'm going to show you the Amish masonry stove that heats an entire house on 1 cord of wood. A heating system standard in European farmhouses for 300 years, before the natural gas industry made it disappear. The numbers on that one are going to make you angry. And you should be. Hit subscribe, because that story is one you need to hear before heating season.